So begin by defining tangents and derivative of a function at a point, and then give the general definition of a derivative of a function and discuss a few rules on differentiation. So we'll begin with the concept of tangents. So tangents or tangent lines and the derivative at a point. So we begin by defining a slope. So slope. So the slope of the curve of a function slope, sometimes also called gradient, of the curve y equals to f of x at a point x naught f of x naught. So let's call this point P, is the number we write f prime at x naught, or we give it the letter m, limit as h approaches 0 of f of x naught plus h minus f of x naught divided by h, provided that this limit exists. So this is what we call the slope or gradient of a curve y equals to f of x at a point P with coordinates x naught, f of x naught. So this is the number defined by this limit. And when this limit exists, then we say that the function or the curve y equals to f of x has a slope m or has a gradient m at point P. So let's sketch. So if this, for example, this is a Cartesian plane, so this is the origin, and I have an arbitrary curve y equals to f of x. So if this is the point of interest, this is where I have x naught. This is the point P. So this line so this is where I have P, x naught, f of x naught. So this black line is what we call the tangent. Called the tangent of tangent line. So we can say the equation of the tangent line or simply the tangent to the curve at P is the line through P with the slope M. So, for example, what I've drawn in this diagram, if this is a arbitrary curve y equals to f of x, and this is x naught, so this point here, this line passing through this point P is what we call the tangent or tangent line to the curve at P. So the equation of the tangent line in the point slope form is given by y minus f of x naught equals to f prime at x naught, x minus x naught. So this is the equation in the point slope form of the tangent through point P as given the definition above. And you can always transform this equation in the form y equals to mx. So that's what we have. Then from your high school work, if I draw another so this straight line that meets tangent at 90 degrees is usually called the line which makes 90 degrees to the tangent line at point P is called from your form 4. What name do we give to this line? Which is making 90 degrees to the tangent. Normal, correct. So this is called normal or normal line. Now, we know that for perpendicular lines, the product of the gradients is always -1, where M1 and M2 are the slopes. So if you multiply slopes of two perpendicular lines, you get -1. So which means M times M2 is -1, which implies M2 is -1 over M, or -1 over F prime at x naught is the slope of the normal to the curve y equals to f of x at point P. So therefore, we can say the slope, the point slope equation of the normal to the curve at P is y minus f of x naught equals to -1 over f prime at x naught into x minus x naught. And similarly, you can transform this to take the form y equals to mx plus c. So this is the equation of the normal to the curve at point P. So before we give examples on how to compute equations of normals and tangents to a curve at a point, let's define derivative of a function at a point. So definition, the derivative of a function f of x at a point P, at a point x equals to x naught, denoted as f prime at x naught, is given by f prime at x naught is limit as h approaches 0 of f of x naught plus h minus f of x naught divided by h, provided that this limit exists. So this is how we define derivative of a function at a point x equals to x naught. So is defined by the limit of this difference quotient. So another definition, now give a general definition of a derivative for any given value of x. So the derivative of the function f of x with respect to the variable x is a function f prime of x defined as f prime of x is limit as h approaches 0 of f of x plus h minus f of x divided by h, provided that this limit exists. So this is how we define a derivative of a function f of x. So the limit, remember h is a small change in x. So limit a small change in x approaches 0 of this difference quotient, f of x plus h minus f of x divided by h. So this quantity f of x plus h minus f of x divided by h is called a difference quotient. And this h is a small change in x. So sometimes we write h can be written as delta x, or we can write in this form. So this is how we sometimes write h, small change in x. And then this quantity is called difference quotient. So I want you to call this 1. This definition of the derivative of a function f of x given by limit as h approaches 0 of f of x plus h minus f of x over h. I want us to give it the name equation 1 or formula 1. Then if we let z to be x plus h, then what will be the value of h if z, we replace x plus h by z? What will be the expression for h?
Z minus x.
Correct, z minus x. And h approaches 0 if and only if z approaches so if z equals to x plus h or h equals to z minus x, what happens when h tends to 0? Z will be approaching which number or which value? As h approaches 0, z approaches
X.
x. We can actually see here, even if you do direct substitution, if where there's h you put 0, then z equals to x. So z approaches x. So formula 1 i.e. limit h approaches 0 of f of x plus h minus f of x divided by h, which is actually the derivative of f prime of x, becomes f prime of x will be limit. So h approaching 0 means z approaches x. So we'll have z approaches x Then where there's x plus h, we replace by z. Then this remains to be f of x. And where there's h, we put z minus x, provided that this limit exists. So I want us to call this 2. So I'll call this one 2. So 2 and 1 represent the same thing of defining the derivative of f of x. So you can define f prime of x using this formula given in 1, or you can use this formula too. Both of them imply the same thing. So having that definition of derivative, so note when we compute derivative using formula 1 or 2, we say that we are differentiating by definition or using first principle. So whenever you compute derivative using limit definition, we say you are differentiating using definition, or you are differentiating using first principle. So if f prime of x exists at a particular x, we say that f of x is differentiable. Or in simple terms, has a derivative at x. So when f prime exists, f of x exists, f prime of x exists, then we say that f of x is differentiable. Then if f prime of x exists at every point in the domain of f, we say, or we call f of x differentiable. So then differentiation is now the process of calculating or finding a derivative. So the process of calculating or computing or finding a derivative or derivatives is called differentiation. So differentiation is a process of computing or calculating derivatives. And there are many different notations on how to represent a derivative. So this is so if you have a function y equals to f of x, then the derivative can be denoted as f prime of x, or you can write it as df dx, or you can write it as dy dx, or you can write it as d dx of f of x, or you can write it as d f of x, or you can write it as d sub x f of x, or you can write it as y prime, or you can write it as f prime, or you can write it as y dot on top of y, or you can write it as f, then you put a dot on f. All these are different ways of writing derivative of a function y equals to f of x. So it's always good to know these different ways, because depending on the textbook you are using, they may have different ways of denoting derivative. So all these mean the same thing. So let's do some appetizer problems on tangents. So find an equation, find an equation of the tangent and normal line to the graph of f of x equals to x squared at the point x equals to 5. So what you need to do is to get a point, the value at x equals to 5, and then get the derivative at x equals to 5, then substitute into the point log form equation of the tangent line and normal line, then simplify to write your answer in the form y equals 10x plus c. So solution. So x equals to 5 implies f of 5 will be given by 5 squared, because f of x is x squared, so which is 25. So the point x naught, f of x naught is equals to 5, 25. So where is x naught in the point slope form, we replace by 5, where is f of x naught to be replaced by 25. So the derivative at 5, by definition, it will be limit as h approaches 0 of f of 5 plus h minus f of 5 divided by h. This by definition. So f of 5 is given by 5 squared, which is 25. Then f of 5 plus h. How do we get f of 5 plus h? What is
5 plus 25.
If f of x equals to or is x squared, what is f of x plus f of 5 plus h?
5 plus h into bracket squared.
Yeah, so it would be 5 plus h squared. Then this is the same as 5 plus h times another 5 plus h. So we'll have 25 plus
Plus 10h plus h.
5h.
10h plus h squared. Or you can do the long way as 5h plus 5h, then plus h squared. You get 25 plus 10h plus h squared. So which implies that f of 5 plus h minus f of 5 will be given by 25 plus 10h plus h squared, then minus 25. So this is the easiest to
10h plus h squared.
10h plus h squared, which can be written as h into 10 plus h, because h is common. So this implies that f prime at 5 is the same as limit as h approaches 0 of now h into 10 plus 5 divided by h, because it's the simplification of f of 5 plus h minus f of 5. So by doing so, h and h cancels out. So which will be limit as h approaches 0 of 10 plus, this is h, which will be, when you get the limit,
10.
10. Because you're simply going to have 10 plus 0, which is 10. So the slope of tangent at 5,25 is 10. So equation of tangent is given by y minus 25 equals Remember we said that if you want to find the tangent at the point x naught, f of x naught, then the equation is given by y minus f of x naught equals to f prime at x naught into x minus x naught. Yeah, so this is the formula. So this is what I want us to use to get the equation. So it will be f prime at x naught. Remember, x naught in this case is 5. So f prime at 5 into x minus 5. So we'll have y minus 25 equals to
C20.
like what?
10.
10 into x minus 5. So I want you to open the brackets and simplify and tell me if you write the equation in the form y equals to mx plus c, we'll have y equals to
10x minus 50 plus 25.
which is reduces to
10x minus 25.
minus 25, correct. Good. Then what would be the slope of normal? In this case, slope of the normal, if slope of the tangent is 10,
Negative 1 over 10.
yeah, so it's usually given by negative of 1 over f prime at x naught. So this will be negative 1 over 10. So equation of the normal is actually, it takes the same structure, only that this part is what changes. So we'll have y minus 25 equals to negative 1 over 10 into x minus 5. So we'll have y minus 25 equals to minus x over 10 plus a half. So if you are to rewrite this in the form y equals to mx plus c, so we'll have y equals to negative 1 over 10x, then plus plus. If you are to write it as an
51 over 2.
51 over 2. Good. Then example 2, compute f prime at 3, where f of x is given by x squared minus 8x. So solution. So here, f prime at 3 is by definition limit as h approaches 0 of f of 3 plus h minus f of 3 divided by h. This by definition. So can you give me the value of f at 3? So f at 3 means we replace x4. What would be the expression for f of 3 without simplifying?
Negative
Before simplification,
15.
f of 3 will be
Negative 15.
Okay, how do I getting negative 15?
3 squared minus 8 times 3.
Yeah, 8 minus 3. So it will be 9 minus 24. So you say minus 15.
Yes.
Okay. Then f of 3 plus h will have 3 plus h squared minus h into 3 plus h. So what is the value of 3 plus h squared?
Nine plus 6h plus h. Oh,
So
sorry.
9 plus 6h plus
H squared.
h squared. Then this will be minus 24, then minus 8h. So when we simplify, we get h squared minus 2h, and then 9 minus 24.
Minus 15.
Minus 15. Correct. So this implies that f of 3 plus h minus f of 3 will be h squared minus 2h minus 15 minus 15. Because this is the value of f of 3. So this reduces to
H squared minus 2h minus 3.
h squared minus 2h, because minus 15 plus 15 is 0. So which you can write this one as h into h minus 2. So therefore, f prime at 3 will be limit as h approaches 0. Now the simplification of the difference quotient numerator is h into h minus 2 divided by h. Then h and h cancels out, so we'll have limit as h approaches 0 of h minus 2. So what will be the value?
Negative 2.
Negative 2. Yeah, so that becomes the answer. Then number 3, find f prime of x and tangent of f of x at x equals to 4, given f prime of, given that f of x is given by root x. So everything actually will result from the definition of the derivative of a function f of x. So by definition, f prime of x is given by limit as h approaches 0 of f of x plus h minus f of x divided by h. This is by definition. So provided that this limit exists. So that's how we define the derivative of a function f of x. So f of x is root x. This is what is given in the question. So then now, this implies So what will be the value if f of x is root x? What is the value of f of x plus h?
Root
Okay.
x plus
Root x plus h.
Yeah, root of x plus h. So then now we can say f prime of x will be limit as h approaches 0 of root x plus h minus root x divided by h. Now you see the problem now reduces to what we were doing last time on computation of limits. If you have to do direct substitution, what do you get? What will be the value for numerator if you directly substitute h for 0? Numerator will be
0.
0.
0. Denominator?
0.
Also 0. So 0 by 0 is undefined. So which tells us that direct substitution cannot help us to compute this limit. So what would be the best method to work out this limit?
Rationalization.
Rationalization, because we can say root function, correct? So this would be limit as h approaches 0 of root x plus h minus root x divided by h. Then we multiply by the conjugate of this, which is root x plus h plus root x, then divided by root x plus h plus root x. So we rationalize. So what is the simplification of the numerator? This will be limit as h approaches 0 of, in the numerator,
X plus H
X plus h minus,
x plus h
minus H.
minus x.
minus x, because these are difference of two squares. So a minus b, a plus b is the same as a squared minus b squared, where a is root x plus h, b is root x. So when you substitute, you find that the square of this will be x plus h, the square of root x is just x. So this is what we'll have. Then denominator will be h into root x plus h plus root x. So this one you don't have to open, just leave it the way it is. It will cancel out, h will actually be cancelled out after reducing the numerator. So this will be given by limit as h approaches 0, x plus h minus x is h, divided by h into x plus h plus root x. Then at this point now you can cancel out h. So h and h cancels out. We'll have limit as h approaches 0 of 1 over root x plus h plus root x. So when now you directly substitute, the denominator will be 1 over
4. 4.
So when you put 0 for h, this first part will be square root of
Square root of
Root X.
x, because x plus 0 is x, then plus square root of x. So what is root x plus root x?
2 root X.
2 root x, which you can rationalize this by multiplying by root x. So we'll get root x divided by 2x.
Mbona x imebaki na tulipewa huko x equals 4.
4.
Where?
In the question you gave us that x is equals to 4.
Okay, we are not yet done. With this here, the first part of derivative. We haven't completed the problem.
Okay.
Yeah, the first part was to find f prime of x, but now we need now to get the tangent of this function at x equals to 4. Okay.
Yes.
Yes. So f prime at 4 will be 1 over 2 root 4, which we have said the same as root 4. Okay, so square root of 4 is? Yes.
2.
2. So 2 times 2?
4.
4. So this will be 4. Check that. Also, when you say square root of 4 over 2 times 4, you'll get still a quarter. Is it true?
Yes.
Yeah. So then this is the slope, this is the derivative at the point x equals to 4, which is the slope of the tangent. So what is the value of the function at 4? If f of x is root x, what is the value of f of 4?
2.
2. So this will be root of 4, which is 2. So the point is 4, 2. So we know that the equation of the tangent is given by will be given by y minus f of 4 equals to f prime at 4 into x minus 4. That's just by definition. So we'll have y minus 2 equals to 1 over 4. That's the slope, x minus 4. Kindly simplify this and tell me the equation in the form y equals to mx plus c. When you open brackets and rearrange terms, we'll have y equals to
1 over 4x plus 1.
Plus 1.
So this will be the answer to that problem. So more examples using first principle. Compute the following derivatives. Compute the derivatives of the following functions. So let's say the first one, f of x is x power 3. Second one, f of x is 2x squared plus 4x plus 2. Or say plus 4. Or say even plus 5. No problem. Remember, we said first principle also means by definition. So to work out this, you say, we know that the derivative f prime of x is given by limit as h approaches 0 of f of x plus h minus f of x divided by h. So in first case, 1, f of x is given by x power 3. So this is what the equation is. So if f of x is x cubed, what will be x plus h, f of x plus h?
Into bracket x plus h cubed.
Correct. So which means then you have to multiply this thing by itself 3 times. You can use binomial expansion that you did in Form 3 to get the expansion of this as x cubed plus 3x squared h plus 3x
3x.
h squared plus h power 3. Just check your Form 3 work on binomial expansion. That should be the expression. Or you can just do the manual way. You expand this, get the answer for this product. What you get multiplied by x plus h. When you reduce it, you get this as the expression. So f of x plus h. So this implies f of x plus h minus f of x will be x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed. So that will reduce to
3x squared h
3x squared h
plus 3x h squared
3x h squared
plus h cubed.
h cubed. So when we factor out h, we get h into
3x squared plus
3x squared
3xh
3xh
plus h squared.
plus h squared, correct. So therefore, this implies f prime of x will be limit as h approaches 0. Now the numerator is h into 3x squared
X squared
plus 3xh plus h squared. Now denominator remains to be h. So h and h cancels out. So this will be limit as h approaches 0 of 3x squared plus 3xh plus h squared. So remember, this limit is in terms of h. So we are substituting where there's h by 0. We'll have 3x squared plus 3x times 0 plus 0 squared. So that reduces to
3x squared
3x squared, correct. So we are saying if y is x power 3, then this implies dy dx or f prime of x is 3x squared. If you remember your Form 4 work, this is actually the correct answer. Then part, I hope you can do the same thing for part 2. If I assume that you can work out number 2, will I be making a fair assumption? This one.
No.
So you have f
Just
of
do
x.
it.
Okay, fine, no problem. So f of
And
x
you
is
will-
given by 2x squared plus, is it 4x? 4x plus 5. So this part B, so this is what is given as the function. So this implies f of x plus h will be 2 into x plus h squared plus 4 into x plus h plus 5. Then this will be now 2 into x squared plus
2xh
2xh plus
h squared
h squared, then plus 4x plus 4h plus 5. So when I multiply, I'll get 2x squared plus 4xh plus
2h squared
2h squared.
2h squared then plus 4x plus 4h plus 5. So therefore now, by definition, f prime of x is given by limit as h approaches 0 of f of x plus h minus f of x divided by h. So this is the definition of the derivative using definition. Then this will be limit as h approaches 0 of now. This first expression for f of x plus h is this. So I'll have 2x squared plus 4xh plus 2h squared plus 4x plus 4h plus 5. Then we are subtracting f of x. So when you subtract, each term of f of x will have a negative sign. We'll have minus 2x squared minus 4x minus 5. I hope you understand where I'm getting my minus signs.
Yes.
Yeah. So by doing so, some terms will cancel out. This term and this term cancels out. This term and this term cancels out. This term and this term cancels out. So we'll have limit as h approaches 0 of 4xh plus 2h squared plus 4h divided by h. Then what is common in the numerator?
H.
H. So you write this as limit as h approaches 0 of h into 4x plus 2h plus 4 divided by h. So what follows?
We cancel out H.
Cancel out h and h. So which will be limit as h approaches 0 of 4x plus 2h plus 4. Remember that the limit variable is h, so directly substitute where there's h by 4. We'll have 4x plus 2 times 0 plus 4. So the final answer will be
4x plus 4.
4x plus 4.
Plus 4.
So this will be the correct dy dx. So I give a 5 minutes break, then come back to do rules of differentiation.